Alright, this is the quiz review video, which will hopefully be short, sweet, and to the point. This is a picture that was on homework 32. What I want you to do with it right now, in order to get ready for this quiz review video, is look at each point in the diagram, and I want you to think, does each point have potential energy, kinetic energy, or both? So first, think about that. What does each point have? Maybe pause the video, decide what you think. Okay, here we go. Point 1 has potential energy. It is at its highest point, and the problem text told us that this is where the car starts, and it starts here from rest. So it has no kinetic energy, it's not moving, has only potential energy. Since the bottom of the roller coaster is this line right here, and all of the heights are measured from that line, we can safely assume the problem is saying that that should be our zero. That means that at point 2 there is no height, and the energy is all kinetic. And then at point 3, you'll notice that point 3 is lower than the initial point, so there's some difference in heights. That means that not all of the energy is potential. Now there definitely is potential energy there because there is a height, so we know this has potential. But because it's not back to its original height, the energy isn't all potential. There's still some left over from what we started with. So whatever's left over must be kinetic. Also, we could tell that because the car eventually reaches point 4. The only way it could get to point 4 is if it were still moving at point 3. So it must be moving there, therefore has kinetic energy. At point 4, the car definitely has a height, so it has potential energy. But that, once again, is lower than the original height, so the energy isn't all back to being potential, and what's left over must still be kinetic. So at these 2 points, it has both types of energy. Okay, what I want you to do next is think about where does the car have the most potential energy? Where does the car have the most kinetic energy? The most potential energy happens at its highest point, so right here at point 1 is most potential. And because we know that total energy is conserved, the amount can't change, just the type, the maximum kinetic would have to be at the lowest point, most kinetic. Okay. Important things to know for the quiz. You should be able to answer questions like that, label energies in any given situation. You should also know what the energies are like at every single point. So at these places I'm marking, think about what the energies would be like. Potential, kinetic, both. Okay. Moving on to the next couple things. And in the free response question, you're going to have to use net force at some point. So remember that whenever you're asked a net force question, there are some steps you need to take. Pretty much any question with forces actually you need to take this step. Draw a free body diagram. 2, every object gets its own Fnet equation. And then you give all the forces on an object in one dimension. If there are multiple dimensions involved, you might have to do an Fnet x and an Fnet y for each object. Okay? Basically, my point is, remember Fnet equals ma. And remember that whenever you're dealing with forces, so any problem that has a force in it, you should draw a free body diagram. Okay, any problem that has forces, be sure to draw a free body diagram so you can see what's going on. And finally, you need to be able to use the spring potential energy equation. PE equals 1/2 K x squared, where K is the spring constant and x is displacement. We're going to practice this a lot in the lab on Sunday, and you can expect a question that requires you to notice that at some point energy in a situation is converted into spring potential, and then figure out some things about the situation. Final thing I want to add in. Something you should know from geometry class, but just in case. Anytime you have something that is part of a, I need to be able to draw a circle better. Let's do this a little better. So anytime you have something that's part of a circle, so let's say I had a track where the first part is part of a circle, and I put an object right here. Whatever the radius of the track is, if you release the object from the very middle of the circle on the side, the height of that object, sorry, radius should have been drawn out here. The height of the object is also the radius of the circle. Okay? So anytime we have something released from the halfway point on a circular track, that object's height is half a circle, which is the radius. I need to know that because I'm going to give you a situation on one of the free responses where you're using PE equals mgh, and if you don't realize that the height is the radius of the circle in that situation, you'll be very confused. So height, if you release an object from halfway point on a circular track, the height is the radius of that circle. All right. If you've looked at this video, made sure you know how to answer all the questions on homework 32, and you have done the review questions that I posted that are in the Princeton book, should be good to go.